Today we're going to talk about what actually is energy. And we're going to learn what the unit of energy is. Now, when we talk about energy, very often we think about work. Suppose I have these concrete blocks here, and if I have to lift this concrete block from the floor to the table, I will have to do a work moving it from the floor to the top of the table. Now, if I do further work by moving the concrete block to the top of the bookshelf, I would end up doing, in this case here, twice as much work, because the height of the bookshelf is twice the height of my table. So in a sense, work is proportional to the distance, particularly in the vertical distance when I'm lifting the block up, is twice the weight, twice the height, therefore I'm doing twice the work. The first point. Now, if on the other hand I have two concrete blocks and I need to lift these two concrete blocks from the floor to the table, it would be equivalent to saying the work done, I lift one concrete block on the table, and then I lift the second concrete block on the table. And therefore, the amount of work that I've done will be twice that of the work I do for lifting one concrete block. So, in a sense, the amount of work is proportional to two factors. First factor being the height or the distance that I've moved the concrete block. And the second, so what we say work will be equal to proportional to the distance I have moved. So if I move twice the distance, I've done twice as much work. And also it's proportional to the force I have to use to lift up the concrete block. And if I have two concrete blocks, I would need to exert twice the amount of force to lift the concrete block. So what we have right here, the definition of W, or the work, equal to the force that I have exerted on the concrete blocks times the distance I've lifted up the concrete blocks. So W is equal to F times D. Now the next question we want to ask then is, what is force? And this is a notion that we are very familiar with in our everyday life. If we exert a force on the table, the heavier I am, I would be exerting more force on the table. But I'm not doing much work because the table is not moving. Unless I'm pushing the table out, and I really have to do quite a bit of work because there's friction that is opposing my force on the table. So the force is then due to the force of friction. And if I move the table by a distance of D, again, I've done a work of F, which is exerted by the frictional force times the distance I move on the move the table by a distance of D. Now, frictional force is a constant force, but very often we define force in terms of acceleration. According to Newton, Sir Isaac Newton, force is really defined as something that causes a mass to accelerate at a rate of A, and the acceleration is measured in terms of meter per second squared. That's an acceleration. And mass, in this case here, is measured in terms of kilogram. And therefore, the unit of force here really is the unit of Newton, defined to be equal to kilogram times meter per second squared. Now, it so turned out that if you think about lifting concrete blocks, the amount of force that would be exerted by gravity, say I have this concrete block here, a mass M, and there will be a force exerted on the mass which is equal to M times G, and G is equal to 10 meter per second squared. So in a sense, if we drop the concrete block down, it would act according to gravity, it will drop down, and the acceleration of that would be 10 meter per second square acceleration for it to come down. So the force that, according to Newton, which is exerted on the concrete block is m. In this case here, could very well be 1 kilogram, and it's a force of 10 meter per second square times 1 kilogram, and therefore it would be a 10 Newton force on a concrete block that is 1 kilogram heavy. All right, so in a sense, if you look at it, what you see is that if I think about the force that acts on the concrete block, causing an acceleration of A, and the force in fact is equal to the gravitational force m times g, and therefore if you cancel out the m, then the acceleration of the concrete block is equal to g, in this case here, equal to 10 meter per second square. All right, so let us now go on to do some exercises to learn more about work as a particular form of energy. Now we're going to today look at what if I need to lift a weight of 1 kilogram. So let's review a little bit of what we've learned so far. We have force equal to ma, and the unit of that is Newton, given by kilogram meter per second square. So work would then be equal to F, the force, times the distance moved, and the unit would then be called a joule, Joule. A joule would be equal to, the unit of that would be Newton meter. Or if you want to express it, it would be kilogram meter square per second square. So that's the unit of work, and that's called a joule. Today we're going to do some exercises. And the first exercise, we're going to ask how much work is done to lift 1 kilogram to a height of 10 meter. Now, that's really simple because capital M, mass, is equal to 1 kilogram. And therefore the work is equal to the force that acts on it, m times g, and then you have to lift it by a height of 10 meter. So that gives you 1 kilogram times g, which is 10 meter per second square, times a distance of 10 meter. And therefore that is altogether 100. And the unit of that kilogram meter square per second square would be equal to 100 joule. So it would take about 100 joule for me to lift 1 kilogram by a distance